Hi guys, today I'm going to be working through the examples from 1.7 of your Year 11 Jack Plus textbook, and we're looking at bisection and lengths of line segments. So the first thing we need to know is the midpoint of a line, and this is actually a pretty easy one because it's just the average of the x value and the y value. And if you think about it, I'll just draw a little picture here. Well, if you have a line segment that looks like this, and just say this is a 1 and a 3, and then this is a 5 and an 8, well then you can see that the x values, which are going from here to here, if we wanted to find the middle, well, we're finding the average of those. So this first x value being 1, the second x value being 5, we could say 1 plus 5 divided by 2, that would give us 3, and that would mean, well, 3 is right in between. And I mean, you can see that there's an even amount of space on each side. So our midpoint would have an x value of 3. And furthermore, if you want the y value, well, here's a 3 and here's an 8. And then if we want to go right in the middle of that, then that's going to be 8 plus 3 divided by 2. And that's an 11 on 2, and we're just going to leave that as 11 on 2. So like I always say, for methods you want to just leave improper fractions. Unless it asks for decimals, you don't need to do mixed numbers. And keep in mind that if it was something like 10 on 4, well, this would not be okay. You would have to simplify it to 5 on 2. But if it's 11 on 2, that's fine. We can't simplify that any further. So look, let's do this this question, and we don't need to really look at to draw it out here. I'm just going to do it straight up. So -3, 5 and 7, -8 are our 2 points. I'm going to label them x1, y1 and x2, y2. And really the place where people get a little bit unstuck or undone is where they accidentally sub in the wrong values. So for example, people might see this as y2 and this is y1, accidentally swap them around, and then of course that's not going to work. So I think the best thing you can do is just label them, whether you're doing midpoint or length of the line. It's a really good idea. So look, let's sub it into the formula. So midpoint, and of course that formula is given because of what we did here, and it's going to be x1 -3 plus x2, which is 7, over 2, comma, and then our y value of 5 plus -8 over 2. Let's make it neat. And -3 plus 7 is 4 over 2, and 5 plus -8, so that's 5 minus 8. That's -3 on 2. So this, we certainly won't leave it like that. 4 divided by 2 is 2. 2, and -3 on 2 we will just leave as -3 on 2. There's absolutely no need to write it as -1.5. And a rule of thumb is, if you're not sure what is an exact decimal, I mean 1.5 or -1.5 is exact, but if you're not sure, you shouldn't convert it, just leave it as a fraction. Let's move on. The next question is telling us to find the equation of the perpendicular bisector of the line segment joining A and B. So look, I'm going to draw a picture and I'll explain what we're talking about by a perpendicular bisector. So A 6, 3, so I'm going to put a point here, call it A 6, 3, and then -8, 5. So I'll put it, I don't know, somewhere. I might put this one up a little higher. Let's start again. So maybe this, A 6, 3, and then B -8, 5. So let's put that somewhere here. Oh, no. That was a bit silly. So here, A 6, 3, and of course 5 is higher than 3, so we'll put it here, B -8, 5. And look, I mean, it doesn't really matter, you know, it's not, we don't need the picture of the line and the A and B points, but you know, we don't want it to have a positive gradient if it's negative. Let's now see what they're talking about with a perpendicular bisector. So perpendicular means that the line is going to make they're going to make right angles, And bisector means it's going to be right in the middle. So at the center of this line, we're going to have another line, which is the perpendicular bisector. It's going to make a right angle, and this is our perpendicular bisector. So we're finding the equation of that line. So step one, I guess we could say understand. And the understanding the word perpendicular bisector really is what we need to do, and that's given by this. You don't need to draw that every time you do a question like this. You just can think about it and think what they're referring to by perpendicular bisector. The second thing would be to write the general equation. Now, I always use y equals mx plus c. You could use y minus y1 equals mx minus x1. That's another equation we could use. But you'll see I always use y equals mx plus c. I think that if there's one thing to remember, it's much easier than remembering two, or in some cases more than two. So step 3, let's find the gradient. Now, we have to know what perpendicular means. Perpendicular is opposite gradient. So, well, our original line A and B, let's find that gradient for a start. So the gradient of AB is going to be, well, we can use the rule y2 minus y1 over x2 minus x1. So let's see, I'm going to label this x1 y1 and x2 y2. So again, I'm labeling them so that there's no little silly mistake that then causes the whole thing to be wrong. So y2, 3, minus y1 is 5, over x2 is 6, minus, now be careful here, it's a double negative. So minus negative 8, so that's going to be plus 8. So 3 minus 5 is negative 2, over 6 plus 8 is 14. So this gives us negative 1/7. So our gradient of AB is negative 1/7, and that's fine, but now we need to find the opposite gradient. So I'm just going to scroll over here a little bit. So neg 1/7, and we're going to be turning that opposite. So we flip it, and we change the sign. So you could also use m1, m2 equals neg 1, and you could solve for the perpendicular gradient. But I think it's just quite nice and easy to flip it and change the sign. And of course, 7 over 1, that's 7. So we don't need the over 1. It's a bit silly there. So now I can say I've got the gradient. That gives me y equals 7x plus c. So I'm almost there. I've got one of the variables, the m, the gradient value. I now, step 4, I need to find c by subbing in a point. And if we look at the picture again, we can see this and this are not the points we would sub in, because those are not on the perpendicular bisector. The perpendicular bisector is the pink line. What we need is this pink point in here. And it's the bisector, and bisector means it cuts in half. So it's going right through the middle of AB. So just like we did a second ago where we found the midpoint of 2 points, we're going to find the midpoint of A and B. So neg 8, 5 and 6, 3. Let's find the midpoint, because the midpoint is where the perpendicular bisector goes through. So x1, y1, x2, y2. So let's say x1 plus x2 over 2, and y1 plus y2 over 2. So midpoint is negative 8 plus 6 is negative 2. 5 plus 3 is 8 over 2. So that gives us neg 1, 4. So that's our midpoint. And we can see, I'm just going to put that on here. We can see that the pink line is going through there. So now we can sub that in to find the value of C. So y equals 7x plus c, and our point is, neg 1, 4. So y is 4, x is negative 1, 4 equals negative 7 plus c. Let's add 7 on both sides. We get c equals 11. So our final stage in any maths question is to actually answer the question. And what I mean by that is to put all the information you have together, because your final answer, you want it to be in the form that they require and to include all the information we require. So our final answer is y equals 7x plus 11. And this is the equation, of the perpendicular bisector. So perpendicular, opposite gradient, bisector, it goes through the midpoint of the lines that we're bisecting. So there it is. All right, let's move on. So now we look at the distance formula, and I will draw a picture for you so you can see how the distance formula works. But you do not need to draw the distance formula every time, you just can remember it, but to understand it is really important because you can easily forget the formula, but if you understand why it is what it is, it's easy to derive. So let's say we've got 2 points, and I'm going to say this is 1, 3 and 5, 8. Well, if you want to find the distance of that line, we can connect this up as a right-angled triangle. And we can say, well, let's call this A, B, and C. So you probably already are seeing that we're looking at Pythagoras here, and that's really all the distance formula is, Pythagoras. So to find the length of here, this vertical line, we can see that this is 8. So our top y value is 8. And while our bottom y value here is 3. So to find that length, I can say 8 minus 3. And of course, that's 5. To find the horizontal length, so here for A, well, I can see this is 1 and this is 5. So to find that length, I can say 5 minus 1. And that, of course, equals 4. So I'm just going to take that triangle out. And I can then say, this is 5 and this is 4, and well, then I need to find C, so A, B and C, and then of course C squared equals A squared plus B squared. So now I get C squared equals A, which we found from 5 minus 1 squared, plus B squared, which we found from 8 minus 3. And C is our distance. So you see, this is why the distance formula, the distance squared, equals 5 and 1 are our x values there. So this one is x1, x2 minus x1, and this is y2 minus y1. So y2 minus y1 squared plus x2 minus x1 squared. And actually I've swap them around there. It doesn't matter which ones you do first, but for the sake of being, more, clear, I will write it like this. Notice that here in the middle of the two sets of brackets we have a plus, and that's because of c squared equals a squared plus b squared. C squared does not equal a squared minus b squared, so be careful. The second thing is that in the brackets we have the minuses, and the reason we have the minuses is because to find those lengths of A and B we need to subtract. And it's pretty clear why we need to subtract there, because we're finding the difference between the two x or the two y values. But people stuff up the distance formula because they mix up where to put the negatives and where to put the positives. So look, in other words, we can say then the distance is root x2 minus x1 squared plus y2 minus y1 squared. And in this case, well, that's going to be the distance equals square root of 4 squared plus 8 minus 3 is 5, 5 squared. Distance equals root 16 plus 25. And distance equals 36, 41. So in this case, we can't simplify this, this root. If we could, then we'd break it down. So we will look if you can simplify. And in this case, we were not given units. We weren't told this is meters or centimeters or anything. So I'm just going to write units at the end. So it's important to consider that they are units, not units squared or anything like that. And if it was in meters or centimeters, you would need to write that. So look, let's do this one here. And I'm just going to apply the formula that we derived there. So this is going to be distance equals root, and I'm going to label x1, y1, x2, y2, and it's x2 minus x1, so that's going to be 1 minus minus 2. Note the double negative, squared, plus y2 minus y1, again double negative. And I feel like they've done that on purpose to make sure people, you know, see how that works. 1 plus 2 is 3, 3 plus 5 is 8. 9 plus 64, so that's root 73. And again, I don't think we can simplify that, which is a little bit of a shame. I would have liked to have done one where we can simplify. So look, that's the distance formula. So we've covered the midpoint formula and the distance formula there, and we've seen how we can, you know, apply those, in particular the midpoint for a perpendicular bisector.